or write set. There are actually two ways we can write our set in. Now we have the first way, which is called the listing or roster method. I hope this my roster is correct. The listing or roster method is the first way we write sets. When I'm writing sets like this, A, B, 1, 2, 3, 4. When all the elements of that set are clearly listed or seen, we are using listing or roster method. When you can easily know the elements without, there is no trick hiding it, or it is clear to see, or even a child can come and tell me what is inside that my set. It's called the listing or roster method. Now the next one is technical. It is a tricky way of representing sets. Most times when we talk with our friends, we want to hide informations. Most times when talking with friends, we would like to hide some details of our conversations, especially when there's a stranger around. So we use codes, right? Yes. So that's what the next method is looking like. The next method is called the rule or set builder. Set builder method. Now this particular type of representation is more like you don't want anybody, any kind of person to easily see what your set is made up of. So what you do is you use a rule. You give a rule. Now from that rule, anybody that is in the same page with me will be able to understand what is in my set. So it's more like a coded way of writing sets. Now I said this before, mathematicians, we don't like theories. We don't like something that is too long. So most times we like codes. We like using codes a lot. So you can say mathematicians are lazy people. Who agree. We like using code a lot. We don't like stress. We don't like having to write things so much. So there's this kind of set you will have. Instead of me listing all the members, I will just use a code. I will just use a rule. I will just use set builders. Like when I come and tell you that my set is S, such that S is prime. I have concluded that set is prime. So if you know what is prime numbers, those are the elements of my sets. Then another one can say S is even, S is odd, S is a multiple of 2, S is a factor of 3, S is anything. Now these two dots I put there is called such that. So the elements of S will come from whatever description they now give you there. Some other questions will come this way. They'll tell you that S, that the set is S such that what should I use? S squared plus 2s plus 1 is equal to 0. They'll give you a formula. So they'll give you a sequence. You use that formula they gave you there to now find what the elements of your S are. So if you can find the factors of S here, those are your S's. Then another one can come this way. S such that 0 is less than equal to S less than equal to 5. This is the one we mostly use. Or they can even say S is greater than equal to 3. Or they say S is less than 3. Whatever. Now, this and this don't mean the same thing. I hope you know that. This one is saying that S are numbers less than 3. That's S are 2, 1, 0, whatever, minus 1. Like you are going down. Less than 3. S cannot be bigger than 3. That's what this is saying. But it did not include 3. See, there is no equality sign there, unlike this one. This one is still less than 3, but it includes 3. Why this did not include 3? So this is an open interval. Why this is a closed interval? It did not include 3 here, but it included 3 here. The same thing here. This one is S is greater than or equal to 3. S is greater than or equal to 3. It's including 3 and it's still bigger than 3. Numbers bigger than 3, including 3. That's 3, 4, 5, 6, 7, 8, like that. And this one I wrote here, the same thing. Now, this, whenever you see an interval like this, these things are called intervals. Whenever you see intervals like this, what it's simply saying is that S is starting from here and ending here. Now, but this one is closed. Can you see the polity? It's closed. When it's closed, it's trying to say that 0 and 5 are also included. But if it's open, it's trying to say that 0 and 5 would not be included. That means you'll be having numbers like the numbers between 0 and 5. That's 1, 2, 3, 4. Well, if it's closed, numbers between 0 and 5, but you're including 0 and 5. That's 0, 1, 2, 3, 4, 5. So that's what we mean by open and closed interval. So this, using this kind of representation, is what we call set builders. So we'll still solve examples on this later, but let's just go on with the explanation of all the details in set first. We have plenty of things to work on, so let's just move on. Now we're going to be looking at the different types of sets. We have different types of sets. We're going to be explaining them one by one, so join me as we continue. Thank you.